All right, so let's keep trucking. So let's talk about what the board would be. So our board for Connect 4 is going to be a collection of checkers in a, what's that, 7x6 grid?
5. Oh, that one.
So 6 rows by 7 columns. 6 rows by 7 columns. Okay, so collection of checkers in a 6 rows by 7 column grid. Checkers are always dropped from the top row and fall as far as they can until they hit the bottom row or land on top of a checker.
Did you ever play that one? Like, it was the checkers game, but it was like the one where you could like move it and slide it back and forth and stuff. Do you remember that one? Did you ever play that?
Move it and slide it.
Yeah, the sliding checkers game. It was like, try looking it up. I'm not joking. It exists.
That's why I should search for sliding checkers.
Yes.
That sounds made up. Sliding checkers game.
Yeah, I can't remember. It had a real name. No, it had a real name. I can't remember. I can't remember what it's called, but I know it exists. I'll find it.
Well, so that's your homework.
I will.
All right.
I remember it.
So, the board is a collection of checkers, 6 rows by 7 columns. Whenever we drop a checker into our board, we add a checker, we always select which column we'll be dropping the checker into, right? And then we drop the checker, it falls down that column until it finally either hits the bottom row or lands on top of another checker. So what we want to do initially is we want to start building some of these mechanics into our board. So we'll start our board off and we're going to then display our board. Initially, our board is a 2-dimensional array of checkers with no checkers in there. That makes sense? The default value for an object when there is not an object present is null.
It was 0.
0 is for integers.
No, but like, yeah. So like the spot in the board is 0. So as long as it's like you check if it's greater than 0, then.
Well, no, I'm saying this is a Java truth.
Oh.
Java truth is we have a null keyword.
All right.
Null is the value of an object that has no value. That's kind of redundant. Is the default value of an object before it has been given a value. So for instance, if we were to say string s, like that, s's current value is null. It's a variable, yes. It's capable of holding an object, yes, but there's no object in there, so it's null. It's nothing. So null is the empty pointer. All right, so we want to create a board, have it control an array, a grid of checkers, but have it have no checkers in it currently, and be able to display the empty grid. Okay, so for now, I think we should display a empty spot as an underscore, a red checker as an R, and a black checker as a B. Fair enough? Okay, so let's go into board. Well, we have to make board first. Create a new class called board. Board is going to have a private checker array. We'll call it the grid. The constructor for board will initialize that array. So the grid is going to be equal to a new checker array, 6 rows by 7 columns. Okay? And it's currently filled up with nothing. I'm going to go ahead and create a method here, public void display, that will allow a board to display itself. And this is going to be our same nested for loop pattern. For int I is equal to 0, I is less than the grid dot length I plus plus. For int j is equal to 0, j is less than the grid at bucket I dot length j plus plus. If the grid at bucket I j is equal to null. If there's nothing there, system.out.print, we'll just do an underscore. Else, display the correct color. We'll leave that blank for now since we're not actually putting checkers in there yet, but I just threw a comment in there. After we deal with each row, we'll do a system.out.println to kick it down a line. All right. So all the display method does, it does the same thing that our nested for loop did before, where it showed all the integers, except in this case, it's showing all the checkers. But since they're objects, we're going to ask the question. If there is not an object there yet, which we know there isn't, because we haven't put any in there yet, then we're going to display an underscore. Otherwise, we'll display the correct color, but that doesn't exist yet, so we haven't implemented it. All right. So this should show us an empty board. Let's go out to driver. We'll create our board, and then we'll say b.display. And this should hopefully give us a tic-tac-toe, a connect for board with a bunch of underscores in it. Okay? Now, typically, when we do when we think about connect for, we have to keep track of which column we have, right? So we need to look at our current columns. So we need to, as part of our display method, we need to rate column 1, 2, 3, 4, 5, 6, 7. So back in board, before we even go through our grid, we're going to do system.out.println 1, 2, 3, 4, 5, 6, 7. And now we have our grid above it.
Wouldn't it make more sense though to do like 0, 1, 2, 3, 4, 5, 6 because that's the bucket names?
Could. Keep in mind though, a human being is going to be using this. Probably not the end of the world. You can choose either one. Now we can play around with the look and feel of this. We might put some spaces in here. And then when we print out the underscore, put a space in there. See what that looks like. Something like that. Okay, now we need to add some mechanics. So what really needs to work to start with is we need to be able to select a column. So whether we do it one-based or zero-based doesn't matter. We just have to make sure we do the math behind the scenes. So we could say if we're going to drop a checker in column 3, we want to go to bucket 0, 1, 2, column 2 in our actual array, and have it fall all the way down until it hits the bottom. Okay? So what we need to do is we need to write a method that allows us to drop a checker in a specific column.
So it should start at the bottom of the column, so the last number, and then I minus or something, and then it should check greater than 0.
I minus or something?
That's what I meant to say. You know what I'm trying to say.
I do.
I just don't very good at phrasing it because I'm trying to speak faster than thinking.
Okay, so the name of the method we're going to write is going to be void, public void, let's call it drop checker, int column.
Wait, so wait. Alright,
Well, don't think ahead yet. Just let us kind of grow through it.
No, but I just thought of something that maybe that wouldn't work as well as I thought of something else. Never mind. Okay, you're teaching.
All right, so drop checker is going to take the column we want to drop the checker into, as well as the actual checker we're going to drop. So if we were to pick column 2 and drop the checker, it's going to make that checker fall as far as it can. We're going to actually provide it with a checker. We're just going to write this mechanic. We're not playing the game yet. Nothing like that. We just want a checker to be able to fall into the slot. Okay? Now, what I'm going to do for right now is we're going to go down to display, and we're going to teach it how to display black checkers and red checkers. So we already know how to do the underscore. If we're in here, so if it's null, that means it's a red checker, or that means there's no checker there. Else, if the grid at bucket I, j is an instance of, so there's our instance of operator, red checker, then we'll do println r, or print r rather. Else, print b. So we just finished up our display method by showing it how to print R's and B's for red checkers and black checkers. Okay. Now, dropping a checker in a particular column. If this is our grid, and we have a checker, so let's say we start off with the empty board, and we drop our checker. I know this board isn't quite representative of Connect 4, but it's close enough. So we're going to drop a checker right here. How do we know how far down that checker needs to go? I think what you were saying is maybe we start from the bottom.
Yeah.
Start at the bottom and say, can we put it here? If it's empty, yes. If it's not, move up a line. Is it empty? Yes. If not, move up a line. So start at the best possible location and then move our way up from there. So we're going to start at the bottom row at the correct column. Okay? And then we'll move up. So it's a pretty similar pattern to what we had before, but instead of starting at row 0, we'll start row.length minus 1. Length minus 1 row. Okay? So if this is our grid, this guy has a length of 5 in this example, right? This isn't our board, but in this example here. So the last legal row is bucket 4. So we'll go from there walking towards the top until we can finally place our checker. Okay, so we know what column this guy's going into. So we're going to say for int I is equal to the grid dot length minus 1, the last row. Keep going as long as I is greater than or equal to 0. Subtract 1 from I each time. Each time through, we'll ask the question, if, and here, just so we don't confuse ourselves, let's just have everything be related to indexes as she suggested, so we don't have to add or subtract. 0, 1, 2, 3, 4, 5, 6. That way we know for a fact that column right here is the exact same column as is in our array. So we don't have to do any funky math in here that's unrelated to what we're looking at. Okay? So we'll ask the question, if the grid at bucket I col is equal to null, that is, if there is nothing there currently, then we'll go ahead and say the grid at bucket I col is equal to C, our checker. We found a home for it. Okay, so a couple different things. So we'll break for now. Break gets us out of this loop. Correct? Yeah. Now, if I finish this loop here, has a checker been placed?
Oh, it's a pre-check thing, isn't it?
Well, possibly. So the question I'm asking here is, after this loop is done, am I guaranteed to have a checker placed?
No, because it hasn't added. Wait.
Am I guaranteed to have gotten in here? The pre-check thing only comes into play if we don't necessarily know that our grid has 6 columns, or 6 rows rather. Okay, but we know it does. So we know that this loop will execute at least 6 times. Well, it'll execute at least once. Okay, we know this loop will execute at least once. So it's not a pre-check thing in this case, because we know as human beings that this guy will execute enough times because of the specific game we're implementing it. But the question I'm asking is, if we exit this loop, have we definitely placed a checker? Under what circumstance would we not have placed a checker? And this isn't really a programming question, this is a Connect 4 question. Yeah, if the whole column's full. So maybe your 5-year-old likes to kind of balance the one on top. Did you do that?
I don't know. He likes dumping them out after.
Oh, I see. So, you know, if we go through this whole loop, we could naturally hit the end of this loop, never having placed the checker. Correct? So we probably need to have this method return something letting us know whether or not a checker was properly placed or not. Because whoever calls this method is probably going to have to let the user know if they made a bad move. Okay? So what we'll do here is we will change our return type for this method to Boolean. So then right here, where we have finally placed a checker, we'll say return true. The method immediately ends. when we return a value. Which means that if I make it here, if I make it outside of this for loop, I was not able to place that checker. Because if I was able to place it, that method died a long time ago. So if I'm still here, I'm going to say return false. I was not able to place a checker.
You should have something cool, like return and like string, like try again or something.
Well, we can respond to this. Whoever calls this can say, if it was false, we can give them a crazy error message or something like that.
All right.
So now to test this, we'll come back out to driver. We're going to display our empty board. So here, that's what it's doing right now, displaying an empty board. And let's go ahead and drop some checkers into.
Can you go back to the board for a sec? Mine's giving me red underlines.
We'll drop some checkers into column 2.
Oh, okay. Thanks. Got it.
So let's drop some red checkers into column 2. So we'll say v dot drop checker column 2 new red checker. So we'll drop 3 of those guys in there. And then we'll display our board. So this should have 3 red checkers on top of each other at the bottom of column 2. Okay. We can then toss a black checker on top of that. So we should have 3 red checkers with a black checker on top. Still in column 2. Let's drop a black checker in column 4. Okay, so seems to be mechanically at least dropping checkers where they need to drop. What happens if I try to drop something in column 7?
It'll be an out of array error.
Array index out of bounds.
Yeah, I got one of those earlier because I messed up something.
So we tried to drop something in a column that doesn't exist. So we probably want to write into our method a little check here at the very beginning in drop checker. If col is less than 0 or col is greater than the grid at bucket 0 dot length minus 1. The last legal column. If either of those things are true, return false. I was not able to place a checker because you gave me a crappy column. So this asks, is the column out of bounds? So now that same code won't crash, it just won't place the checker. Okay. Now we're going to go ahead. Excuse me. We need to go ahead and have the user be asked to make moves. Okay? So we're not even checking for mechanics at this point. What we want to do is we want to have, when the game starts, have it alternate between player 1 and player 2. For whose move is it? Is it red checker or is it black checker's move? Right? So we're going to create a game object. And what's game going to hold? Game will have a board, two players, a pile of checkers for each player, so what, 21 checkers each? Is that right? So a pile of 21 checkers for each player. All right, so let's go into game. Game will have a private variable called of type board called the board. We'll have a private string player 1 name, private string player 2 name, private checker array player 1 checkers, private checker array player 2 checkers. Then we're going to have a constructor. Public game, player 1 name, string player 2 name. So to build a game, we have to ask for the two players' names. Okay, so we'll set this dot player 1 name equal to player 1 name. This dot player 2 name equal to player 2 name. This dot the board is equal to new board. So we'll build an instance of our board. This dot player 1 checkers is equal to a new checker array of 21 checkers. This dot player 2 checkers is equal to a new checker array of 21 checkers. Now we need to fill player 1's checkers up with red checkers and player 2's checkers up with black checkers. Because as all kids know, you have to have fire before you can have smoke. So red goes first. Is that a real rule or do kids just make that up?
Never heard it.
You've never heard that?
Never.
No, see, red always goes first because you can't have smoke. Smoke's black until you have fire. Fire comes first. This makes perfect sense. Okay, so player 1 will always have red checkers in our game because that's the correct way to play, obviously. So we will fill player 1 checkers with red checkers. For int I is equal to 0, I is less than this dot player 1 checkers dot length I plus plus. Now we happen to know that player 1 checkers and player 2 checkers have the same number of buckets, right? So we can actually use that same loop to fill both arrays. Player 2's checkers with black checkers. So each time through this loop, we'll say this dot player 1 checkers at bucket I is equal to a new red checker. This dot player 2 checkers at bucket I is equal to a new black checker. So each player should now have their fill of checkers. So they have a nice little pile of checkers sitting in front of them, if you will. Okay, so that initializes our game. Now, along with players' names and players' checkers, we also need to have private int cur move. Let's see, player 1 cur move, and private int player 2 cur move. We want to know how many moves these guys have made so far. So we want to initialize that as well to 0. So initially, neither player has made a move. All right, now the starting point for our game. We need to at least be able to alternate back and forth between our two players. So we want to create a situation where we ask player 1 to make their move. They make a move, shows a new board, player 2 make your move. They make their move, shows a new board, player 1 you make your move, so on and so forth. Okay? So we're going to have a method here just called start. And this starts our game rolling. So to begin with, player 1 makes a move. And player 1 will be asked to make a move until they have successfully made a move. And what does it mean for them to have successfully made a move? It means that board's drop checker method must have returned a true. That a checker has been dropped. All right, so to start the game, we're going to ask player 2 to make a move. So do, we're doing this in a do while loop because we must ask them to make the move at least one time. Make sense? System.out.print player 1 choose a column. Now we need to be able to read in a number from them. So in order to do that, we need to use our scanner. We've looked at the scanner in here before, right? For reading stuff in from the keyboard. We haven't read anything in from the keyboard? Okay, no problem. So let me just pause this real quick. Just get this do loop out of here. Let's go back to driver. And I will show you how to read stuff in from the user. So we're just going to do another print statement, system.print You can say print, println. This is just our prompt. You don't even have to say it if you don't want to. You can just assume the user knows they're supposed to type something. System.out.print, enter something. Okay, now to read something in, we use a tool called scanner. Scanner lives in java.util. So it'll yell at you and you have to import java.util. And this goes back to me saying that Java is a string-based language. So even though scanner lets us read things in different formats, I prefer to always read things in as strings and then work with them from there. Okay? So we'll say string line, whatever you want to name it, is equal to input dot next line. That will read everything that the user typed in until they press enter as a string. And then I'll just spit it back out. So all my program does right now, it says enter something, creates a new scanner, it waits for us to type something in. This line right here is said to block. So that line blocks, meaning we do not get to this line until the user has finished entering their crap in on this line. So not until the user actually hits enter will we pass that line and go to the next one. Okay, so this program currently prompts them for something, reads something in, and then spits whatever it read in out to the screen, proving it read it in. Make sense? So go ahead and run it. Enter something, blah. Well, I said bah, good enough. And then it spit it back out. Successfully read it in. Okay? So, if I read something in like a number, for instance, column 4, it'll spit out a 4, but that's the string 4. I need to get that into the int 4. How do I convert a string representation of an integer into an int? We wrote our own method first time. Then I showed you the shortcut method, integer.parseInt. We showed us that one, yeah. So the difference here would be line plus 5. I promise you I'll enter 4 in. So line plus 5 there will be 45. Integer.parseInt line plus 5 will be 9. So this line is the string representation of the number 4 that I'm going to enter in. So when I use the plus sign, it concatenates. So this will glue the 4 and the 5 together, creating the string 45. This one down here, I am converting my 4 into the integer 4, then adding the number 5 to it, giving me a 9. So this is how, using integer.parseInt, how we can turn whatever they typed in into a number. So there's my 4. So when I press enter, I'll see a 45 on the first line, and then I'll see a 9. Okay? First one did concatenation because this guy's a string. Second one did addition because this guy's an int. All right, so that's how we can read things in from the user, and that's how we can turn it into a int. So we'll go back into game. We'll go ahead and create our scanner up top here. Scanner input is equal to new scanner system.in. System.in. See, scanner will actually allow you to read in from any input stream, not just from the keyboard. System.in is our standard input stream, which is the keyboard. That's the standard way of getting stuff into the computer. Okay? Just like system.out is our standard output stream, prints out to the screen. Well, you can have other streams that print out to a file or print out to a socket over the internet, things like that. Okay, but system.out's our default one that shows things on the monitor. So we'll build our scanner around system.in. Now, we'll put this in a do loop because we might have to ask them more than once. Do player 1, enter a column. So I create a variable up here for capturing my column. I'll say call is equal to input dot next line. Okay, so now we have the column. Now, since this is player 1's turn, we're going to do what? Player 1 uses red checkers. More importantly, player 1 uses player 1's checkers. Make sense? So, now, which checker is player 1 currently trying to place? The checker at position cur move. Bucket 0. After they've made their first move, the next one will be bucket 1, then bucket 2, then bucket 3, then bucket 4. Okay? So, we're going to try to make a move. So once we have that column entered in, we're going to say while the board dot drop checker. What checker? Well, where are we dropping it? We're dropping it in call. What checker? Player 1. This dot player 1 checkers at bucket. This dot player 1 cur move. Now, call is currently a string. We need it to be an integer. So we say integer dot parse int of call to give us the actual numeric version of that. Now, this currently says keep asking them as long as this returns true. But we don't want it to keep asking them as long as it returns true. When it returns true, that means we successfully placed the checker. We want to ask them as long as this returns false. That means they gave us a bad column. Okay? So we can either say equal false here. So while all of that, basically our call to our drop checker, returns false, or we could also say not all that. So putting not in front of it, not true is false. Okay? I would say beginning programming, equal false is probably preferred. Advanced programming, not is probably better. Equal false is actually kind of redundant. That's saying is false the same as false, instead of just saying not this. But I think this looks clearer. So we're saying do all this crap, that is prompt them to enter something, read it in, while we're going to keep doing this as long as whatever they entered in returned false for drop checker. as soon as we get here, a checker has been dropped by player 1. That's what is true when we get to that line. We have no idea how many times it took them to try. They might have done it on their first attempt. They might have taken 400 attempts to finally get a checker dropped in the right column. Okay? Now, as it's currently written, our program assumes that the user is entering a number. This will crash if they put in like Bob. You know, what column? Well, Bob. Okay? That'll crash because integer.parsent is not going to like us trying to turn Bob into a number. But to keep the amount of code to a relative minimum, we're not going to put that error checking in. So if we got here, that means player 1 has dropped a checker, which means we need to say this dot player 1 cur move plus plus. They just made a move. Then what do? We do the same crap, but we do it for player 2. So I'll copy that code. Player 2, enter a column. We're going to pass in player 2's checkers, which is filled with black checkers, at player 2's current move. And then once it's finally been placed, we'll increment player 2's current move. So as we have this currently written, the start method asks player 1 to make one move, and then asks player 2 to make one move. And then it's over. So we'll go ahead and run that. Let's get that to driver. So again, good object-oriented programming. When we get out to main, main usually looks pretty minimalistic. Game G is equal to new game G dot start. Oh, game takes 2 player names, even though we're not using the player names currently. I don't know why we had it take in player names, but whatever. So I'll go to driver. This is going to be Bob and Mandy. And we're currently not using their names. We just take them in and do nothing with them. We just refer to them as player 1, player 2 from this point forward. Then we're just saying start. So here's our program. Player 1, enter a column. Probably should have shown them the board, but, you know, whatever. Let's go ahead and add that real quick. Just guess. It's a blindfolded Connect 4. All right, so I'm going back into start real quick. Every single time we ask them, we'll show them the current state of the board. So we'll say this dot the board dot display.
How do you like clear it so that you get rid of the previous board?
Probably putting in a whole bunch of lines. I'll actually, I think
But isn't there like a clear function or something?
there might be. I'll check it here in a second.
You can search that website. I'll search it.
Yeah, I think there might just, what I would usually do is just write a quick little loop that just runs through 80 times and does carriage returns. Keep in mind that not a whole lot of programs anymore are console based. There probably is a ASCII character for clear screen. Like \n is carriage return, line feed. \r is just carriage return. There's probably a \/ something that is clear screen. But regardless, this stuff will just be mashed together a little bit. So now that I've, in both of my loops, had to display the screen, go back out here. Now we'll show them the game. Player 1, enter a column. We'll say column 1. Okay, so now it's showing the current board, and notice that player 1 has made their move in column 1. Here's the R. Player 2 will now make their move. We'll do 4. Okay, it's currently over. You only asked them once each. So I didn't have my opportunity to show you the board the second time. So, how often do we want to do this? Well, we want to keep doing this until there's finally been a winner. Okay, well, writing the code for is there a winner is a whole nother challenge. So for right now, we're going to come in here to our game, and we're going to put all of these loops inside of a big while true loop, which just says do this forever. So I just put all the code we wrote, with the exception of the scanner and column declarations at the top, inside of a big while loop. And then Command I on a Mac, Control I does the auto indent to make the stuff look prettier, since I now need all that stuff indented inside the while loop.
What is it?
Command highlight everything that you want to fix the indentation for, and then hit Command I.
Oh.
You could also right click and go to source and then go to
I just didn't realize.
Correct
I had to
indentation.
highlight it first.
yeah, then
Alright,
correct
thanks.
indentation. All right, so what will this do? This will just ask us to keep entering columns forever, because we have no way of checking to see if there's a winner yet. All right, so we're back here. We'll go column 1, then we'll do column 2, then we'll do column 1, then we'll do column 3, then we'll do column 2. Now I'm going to go ahead and put in an 8. Notice it's asking for player 1's turn currently. Still player 1's turn. Still player 1's turn. So we'll put in a 1. Now it's player 2's turn. Oh, I pressed enter before I hit a number. So we got a number format exception because I didn't put in a number. That was the thing where I said we were not going to error check to make sure they pressed numbers. Okay, so as of right now, we have it working so that they can keep playing the game. The problem is the game never knows whether or not there's a winner. So we are going to have to teach the board how to determine if there is a winner. How would we do this? 3 different ways to win. 4 in a row up and down, vertical. 4 in a row horizontal, or 4 in a row diagonal. Go ahead.
I think I could get like the horizontal or the vertical, because like you could just do that for loop that we were doing before, and then it could just keep counting down, and for each time like it detected a red checker or something, then it would like add 1, and then if it added to 4 in a single column, and like each time it moves on to the. And then
But it needs to be 4 in a row.
Yeah, and if it doesn't get to 4 in a row, then like it's just.
Okay, so as soon as if you're doing red checker, as soon as you hit a black, you start your count over?
Yeah,
Okay. That's reasonable enough.
I mean that's probably overcomplicating it.
Well, not necessarily. A working solution is better. A long-winded working solution is better than a short-winded non-working one. All right, so let's take that approach initially.
Maybe.
So we are going to go into board. And we're going to write a method. Public Boolean is winner. And this guy will return true if the current state of the board represents a winning move. Make sense? Okay. So, we're doing this generically. Then we'll create a better version of this. If I'm in his winner, I'm the board. Right now, I'm dumb. I don't know who moved last. I don't know what moves have been made. All I know is about this two-dimensional array filled up with checkers. And I'm supposed to tell you if, yes, somewhere in this grid there exists a winning move, a winning combination, yep. Let's just do verticals initially, okay? Keep it simple. That when we test it, we'll just test it with vertical winners, okay? So, if we're just doing verticals, how would we go through our entire board determining if there's currently a winner? Start off in, we're just doing verticals. Start off at column 0, row 0, or row, maybe start at the very bottom. That's where we're going to find our checkers, right? They're all at the bottom. Start at row length minus 1. Okay, so we're going to have our little loop for int I is equal to the grid dot length minus 1. That's the last row. Actually, we need to rate this a little differently. We want to go through each column, and for each column, we want to go up all the rows.
I was probably thinking rows.
Because we're doing verticals, right? So we want to say this. For each column, go to the bottom of the row and count our way up.
So can we use the same one from the public Boolean drop checker?
Well, we're really doing pretty similar code, but we're actually switching our two loops. Does that make sense?
Yeah.
So our outer loop will count columns. So for int I is equal to 0, I is less than the grid at bucket 0 dot length I plus plus. Because we know the grid at bucket 0 is the same length as the grid at bucket 1, is the same length as the grid at bucket 2. They're all length 7. Right? So for each column, we want to look at the bottom row towards the top row until we run out of checkers. We know that all checkers found will be on the bottom. Okay? So we're going to say for int j is equal to the grid dot length minus 1. J is greater than or equal to 0. J plus plus. So this loop will potentially, I'm sorry, not J plus plus, J minus minus. Start at the bottom, keep going as long as we haven't passed the top, subtract 1 each time. So that inner loop is going to do this. It's going to go from here to here to here to here to here. Unless we run out of checkers somewhere along the way, in which case we'll break out of the loop. Okay? So we'll have a count variable. And before we start processing an individual column, we'll set count equal to 0. We'll zero it back out. All right. Now, we also need to know what our last checker was for its color. Make sense? We need to know what its color was. Uh-oh, this is gonna suck. Okay.
Did I mess that up? with the
No,
idea?
no. It was gonna suck anyways. When we do it the better way, it won't suck. But right now, we're doing it the way I intended for us to do it right now. I want us to take a brute force approach, and then I want us to go and look at easier ways of doing it. So we're fine. So in order to count, we're going to look at what the current checker is, correct? Now, the current checker will either be a red checker or a black checker. If it's a red checker or a black checker, our very first time through, we're going to increment count. We have one in a row, correct?
Can you use index of checkers in an array?
Index of checker, what do you mean?
Like, can you use the index of and then use it of checkers?
The instance of, or are you talking about the index of?
Index of.
That's a string method. Yeah, it won't work for arrays. Okay, so,
Then you can just search for it and then find the closest one and keep going.
well, I think we want to start at the bottom.
Okay, fine.
These are all checkers.
Yes.
Okay, so these are all going to be checkers. We're going to start down here. Regardless of what color this guy is, count is going to go to 1. Then we'll walk up. Count is either going to go back to 0, or it's going to go, well, count is either going to remain 1 over to the other side, or it's going to go to 2. But it's only going to go to 2 if this guy is the same color as this guy. Does that make sense? How do I ask if this is a checker and this is a checker? How do we ask if those guys are the same color? We know how to ask, is this guy a red checker or is this guy a black checker? We know how to ask, is this guy a red checker or is this guy a black checker? But how do we ask, is this guy the same kind of checker as this guy? Get what I'm asking? So what we're going to need to do, we're going to create a variable called last checker of type checker, because we know that checkers can hold either red or black checkers. All right. So inside this loop, we're going to set, when we first start, we're going to set last checker equal to null. It started off as null anyways, but this just explicitly sets it to null, so we know that's the value, because we do not have a checker in there initially. So the very first time through, we will ask the question, if last checker is equal to null, then what are we going to do? We're going to set last checker equal to the grid at row j, column I. I is our outside one. Column will stay static for as we go through all these rows. Row j, column I. So we'll set that checker to that, and we will say count plus plus. That's what happens if this is our first time through where last checker isn't set to anything. As far as we know, we have one in a row, and we don't have a previous checker to compare against. Okay? Otherwise, last checker is currently some checker, currently holds some checker. If that's the case, what are we going to do? We want to know if the current checker is the same color as the last checker. If it is, count will go up by 1. If it's not, then count goes back to 0, then increments by 1. So we have a new, so really count goes to 1 because we have a new 1 in a row. Okay, so we need to ask that question. Is the current checker the same color as the last checker? And the only way for us to really ask that question is by saying something like, if the grid at bucket j, bucket I, is an instance of red checker, and last checker is an instance of red checker if both of those are true statements. If both of those guys were instances of red checker. Then we're going to do what? Count plus plus last checker is equal to the grid bucket J, bucket I. But we'll do this exact same thing if they were both black checkers, correct? So if the current checker is a red checker and the last checker was a red checker, or the current checker is a black checker and the last checker was a black checker, under either of those circumstances, we know we have 2 in a row. Correct? So we'll build an OR with this. So I'm going to surround this whole thing in parentheses. And I'm going to do double vertical brackets, or double vertical lines. And then I'm going to press enter, just to kick it down a line. Java will allow this. It'll make it so this doesn't scroll off the screen so much. And then I'm going to actually steal this exact same code, but change them both to black checkers. Okay. So, if they're both red checkers or they're both black checkers, then we know we have another in a row. And we'll just say count plus plus, set the last checker to the checker we just saw. Else, count is equal to 1, and last checker is equal to the grid at bucket J, bucket I. So we did this line regardless, correct? No matter what happens, we're setting last checker to the checker we just processed. So I'm not going to put that inside the if and else. I'll put it right after the if and else. Why write it twice if it only needs to happen, if it always needs to happen? So outside of our if and else, we'll go ahead and set the last checker.
What happens in that top if and that else too, so you can move it out another layer, can't you?
We absolutely could. Absolutely could. So we are setting the last checker regardless of what goes down. Each time through our for loop here, we're going to be setting our last checker, but not until after we've done all this pre-processing stuff. Okay? Now, before we spin back up, if count is currently 4, what does that mean? We have a winner. Yeah, return true. It means we have a winner. So before I spin back up and check the next row, if count is equal to 4, return true. Make the method immediately end. Make sense? Now, what if we run into things that are not checkers? Well, they'd be nulls. We interpret nulls as underscores, right? But before we even ask, is this guy an instance of something else? Don't we need to make sure that the current checker is in fact a checker?
So do while or just while?
Well, if we're in here, Well, let's do it this way. Every single time through this loop, before we ask, is this our first time through this loop or our 10th time through this loop? If we currently are not looking at a checker, we are done with this column, correct? It's a true statement, correct? So if we're currently done with this column, what do? Go on to the next column, which means we break out of this inner loop. I don't have to worry about checking for a winner because we always check for a winner here at the bottom of a particular column. Does that make sense? That's fine because if we didn't hit this, we didn't hit 4. So in a situation where a column only has 1 checker in it or has 0 checkers in it, for example, we're going to break out right up here. We don't need to check to see if there was a winner if we only had 1 checker. Not a winner, correct? So our code will naturally check for a winner because we would have had to read through 4 checkers that were all the same color in a row in order to declare there to be a winner. So up here, we can just ask the blanket question. If the grid at bucket J, I is equal to null, if we are out of checkers, break. Now this allows us to give a little, remind ourselves about the definition of the break keyword. Break breaks us out of the most local loop. The most local loop is this guy, the for loop that's going through all the rows in the current column. When we break out of that, it'll throw us back up to the outer loop, which moves on to the next column. Does that make sense? It does not break out of both loops. It breaks out of the most local loop. This question says, if we are not looking at a checker, move on to the next column. Make sense? Now, as it's currently written, this is the end of the for loop. End of the for loop for the columns. This is the end of the for loop for the rows. So if I get here, if I get past both for loops, and I'm still kicking, that means I never did this. If I never did this, that means I checked every single column and none of them had 4 in a row vertical winners. Therefore, currently, no winner. So if I am here, there is no vertical winner. And we'll return false.
Why is it trying to correct my spelling in a comment?
I don't know. Well, it does it to mine too. All right. So that's our, I'm going to put a little comment before is winner, just saying currently only checks for vertical winners.
Wait, don't we need to break out if we reach the last column? Don't we need to like break out of that? No, it just leaves it. Okay.
Yeah, it'll naturally get out of that. Okay, so is winner currently checks for vertical winners only. We're going to go back now into our game to test this. So inside of our start, rather than while true, we'll say while this dot the board dot is winner equal to false. Or you could say, while not, the board dot is winner. So while there is not a winner, keep asking questions. Okay? Now, as it currently stands, you may actually have a winner after this guy's moved, but this guy's still allowed to move. But this at least allows us to check it because we're almost out of time. Okay? You might have player 1 wins, but player 2 still gets the move before player 1's declared the winner. Okay, but we'll go ahead and run this. At least this will let us test it. And here, I'll just put a little statement outside of the while loop. System.out.println. There is a winner. We don't know who, we don't know why, we don't know how. But somebody won. Okay, we'll go ahead and hit play. So here's our current thing. So we're going to go ahead and let player 1 win on column 3. So player 1 will move on 3. Player 2 will move on 4, 3, 4, 3, 4. So now we're going to do 3. It's not going to declare a winner yet because player 2 still needs to go. Then we'll do 5, just so we don't technically have a visual tie. And there is a winner. Make sense?
Yeah.
Okay, so not quite a full Connect 4 game. We're going to come back next time. We'll finish writing this and learn some other stuff along the way and actually write some maybe better way of doing some of the things. But for right now, let's go and talk about the assignment. So this is a multi-part project, multi-class project. Oh, and just like last week, if you don't see your grades by if you'll let me say 10 o'clock tomorrow, p.m., is that okay? Well, I don't like falling behind. So if you don't see your grade, let me know by tomorrow night. Wednesdays are my really long days, so I don't know if I'm going to get up in the morning to do it, but I'll try. But I'll get it in by tomorrow night. Sorry about that. It's kind of a pet peeve of mine because historically I think I told you, I've been poor at keeping up at grading. So now I try to stay on top of grading, so it bugs me when I don't. Okay, so any case. But I think mostly you just cared about that you didn't want to be signaled out. Everybody's not getting grades is what happened. Okay, this is CSC535. And we are now on Unit 4, correct? Homework 7? Because next week's our final class, correct? Okay. Okay. Oh, this should be fun. So create a class called card that represents a playing card. You know, like a 4 of clubs, 5 of spades, that kind of stuff. A card has 2 fields, a display value and a suit. A card should be able to display itself. Create a class called deck that represents a deck of 52 cards. The deck should be able to shuffle itself, display itself, and deal a card. Dealing a card should return the card from the top of the deck. Dealing a card twice in a row should not return the same card. That is to say that dealing a card changes the position of the top of the deck. Test your card and deck classes thoroughly. Okay? So, for this assignment, you're writing the beginning mechanics of what you'll need for your final project. Okay? Now, one thing I will tell you is the final project is implementing, well, you can actually already see it on there, right? The final project is implementing a card game using some of these things. Okay? So, questions about what I'm asking you to do there. Create a card class, keep track of a couple pieces of information about a card, just like we kind of created a checker class here. Create a deck class, which is a collection of cards, which is kind of like a board, right? Then shuffle the deck. Be able to display the current contents of the deck, so you should be able to see, here is our deck, likely all in order, depending on how you go about filling your deck. Hint, hint, I would not write 52 straight statements adding cards into your deck. If that's the only way you can figure out how to do it, fine. Technically, it works. But there are some nicer ways that you could fill a deck of cards in not very many lines. Okay? Using things we've learned in the course so far. So fill up a deck of cards with 52 cards. Maybe show all those cards in order initially. Then shuffle it. Show it again so you see they're all jumbled. Prove that your shuffle is working. Okay? So you have to figure out what is a good way of approximating shuffling a deck. You know, how do I jumble up a deck of cards? All right. Then make sure you implement a deal method for your deck so that you could ask the deck to give you the next card from the top of the deck. And if you call that multiple times, it should give you different cards. Shouldn't just keep handing you the top card for the deck and say, yeah, look, it's an ace. Just take it. All right, questions about that? So should not be too bad. Probably the challenging part of this is shuffling. And can't tell if I hope for this or not. Shuffling, when we write it in class, will take all of about 2 minutes. It's like really easy. And you have all the tools you need to do it already. So I'm not going to show you some like secret shuffling trick in class. Everything you'll need to shuffle is already in your toolbox. All right, now paper quickly. This is our last paper. There is not a paper the final week. Final week's all about programming without a exam. Write a 3 to 5 page paper discussing the role of object-oriented programming in modern programming solutions. How does the object-oriented programming compare to procedural programming? Well, we talked about that some today, didn't we? Quite a bit about encapsulating things, stuff like that. So this is very related to what we did in class today. Is procedural programming dead? Discuss the history of object-oriented programming. What was the first object-oriented programming language and what was the motivation to create it? How did object-oriented programming languages evolve? What do you predict to be the next evolution of computer programming? That's always an interesting question. So for that last part, there isn't necessarily right and wrong answers. It's more of an interesting thing from my perspective. Consider what we've done today where we have main. So let's just call this a nightmare in here, right? It's not that many lines of code, but relatively speaking, there's a lot of stuff going on here, right? Look at main. Our whole game. Everything it does is right there. Because all of that crap, game encapsulates boards and players and checkers. A board encapsulates checkers and all the things that the board can do. So all that stuff is hidden inside of these objects so that out here to play our game, it's just that. Make sense? So there's some real benefits to object-oriented programming from a set it and forget it perspective. Once you deal with the details, hide it behind the drywall. We don't need to look at it again until we need to fix something. So think about whether or not there's a level past object-oriented programming. Okay, is there something we can do better? All right, questions about that? Questions, comments, concerns, bribes? Okay, I will see everybody next week.